Hey guys, welcome back to the channel. Today we are going to talk about something really cool and super important for anyone building AI features. It's called MCP or Model Context Protocol. So if you have ever tried to make AI actually work inside a real app, you know the biggest problem is not intelligence, it's context. So in this video, I will break down why context is such a challenge, how developers have been trying to solve it, and why MCP is the missing layer that actually makes AI useful in real world apps. By the end of this video, you will understand how MCP works, its architecture, and even some real life examples, all in a simple, easy to understand way. So let's dive in. When people talk about AI today, they mostly talk about how smart the models have become. Bigger models, better reasoning, better answers. But at the moment you try to put AI inside a real product, you realize something very quickly. Intelligence is not the main problem, but the context is. Let's take a very normal example. A user, imagine that you are building a support chatbot for your app. User comes and asks, when does my paid plan expire? That sounds like a simple question, right? But for the AI to answer this, it needs a lot of information. First of all, who is this user? Are they logged in or not? Which plan they are on? When did they purchase it? Do they have permission to see billing details? AI does not know any of this by default. It does not have access to your database. It does not know your users. It only knows what you tell it. So what do most developers do? They take all this information like user ID, plan details, permissions, rules, and whatever it is, and dump everything inside a one giant prompt. So they say like, here is the user, here is their plan, here are the rules, and now answer the question. So this works for demo, but it works when you have one feature and one prompt. But the moment your app grows, this approach start failing because the prompts become huge, context gets duplicated everywhere, one small change breaks multiple prompt, security becomes scary because you are putting everything inside a prompt, and maintaining it also becomes a nightmare. At that point, the real question is no longer how smart is the AI. How does the AI get the right context safely and consistently is the problem. And that's exact problem is why model context protocol exists. Life before MCP. So before MCP, there was no clean or standard way to give context to AI. So every team, every product, every developer solved it in their own way. Most of the time it looked like this: you had an API, you've had an database, you had some business logic, and then suddenly you have an AI feature. So you wrote a prompt like, here is the user data, here are the rules, here is the plan info, here is what AI is allowed to say, and now answer this question. At first, it felt fine because it was a short prompt. But as the product grew, the prompt started growing too. Once prompt became 5, then became 10, then it converted into 15 lines, and then at last 30 lines, and this continues. So the same context was copied again and again, but slightly different in every place. And if a rule change, you have to update it everywhere. If the permission change, you hope you did not miss a prompt. And there was no real structure. There was no clear separation between data and instruction. There was no standard way to reuse context. There were no safe boundaries for what the AI could or could not access. Basically, the AI was working, but it was working on manual memory. And that's when things starts breaking. And long prompts which were copied for every question. So here is what life actually look like. User ask a question. Before the AI can reply, we first remind it of everything with the help of prompt. It is like talking to someone who forgets you the moment you stop speaking. So user ask, can I upgrade my plan? Us will be sending prompt to AI model like, okay, listen carefully, the user is logged in, they are on basic plan, they bought it on this date, there are the rules, there are the things you must not say, now answer it. Nothing changed, the answer came, and at that time, next question comes in. Then user asks, when will my plan end? Then AI will again, we need to again repeat the same prompt to our AI model. Okay, listen carefully. This is the user logged in, basic plan, bought it on this date. There are the rules, there are the things you must not say, and now answer it. So after some time, the prompts became bigger than the actual question, and this causes very real issues. Responses become slower, token usage goes up, cost increases, and small changes becomes risky. Worst part is you update the prompt in one place and forget to update in the another. Now different parts of your app are telling the AI different versions of the truth. At that point, the problem is not AI anymore. It is how we are handling the context. So why we keep re-explaining the same thing again and again? The reason we keep updating or we keep repeating ourselves is simple, because the AI has no idea who our users are. It does not know our app, it does not know our databases, and it definitely does not remember past questions. So every request we send to the AI is like a brand new conversation. So even if the user is logged in, we if we already know everything about them, the AI does not unless we tell it again. Think of it like that you have all the data inside your system, but AI is standing outside. There is no bridge or no connection between them. So every time AI needs to answer something, we manually carry information from our app and dump it into the prompt. That's why we keep re explaining who the user is, what they are allowed to see, what data they can access. Not because we want to, but because AI cannot reach that information on its own. And since there is no standard way to connect AI with our app's context, we end up doing the same work again and again by sending it in a single prompt again and again. It is not scalable, it is not clean, but for a long time, it was the only option we had. The core question: how can AI help without context? At this point, we have to ask the obvious question. If the AI does not know anything about our user or our app, how is it supposed to help? Think about it. You are building a support chatbot and user asks, when does my plan expire? The AI does not know the user, the database, or the where, what plan they are on, what permission they have, or then all it can do is just guess. It does not magically connect to our database, it does not remember past chats, it does not know your rules. So even the smartest AI in the world is useless without context. That's why developers keep doing the same thing over and over. Let's put everything into a prompt. But as we saw before, that does not scale. It's slow, expensive, and fragile. The real question is, how do we give the AI all the right context safely, reliably, and all in a way that work across the entire application? And that's exactly the moment where MCP or Model Context Protocol comes in. So before MCP, there were a few early attempts like custom integration and RAG. A developer tried all the sorts of hacks to give AI context. So one common way was custom integration. For example, imagine a project management tool and a user asks the AI which tasks are overdue for my team this week. For this, the AI need to know who the user is, which team they belong to, deadlines of all the tasks, and which task they are allowed to see. So what we did was grab all that info in a code and dump it into the prompt. So the prompt looked like Alice team, backend task, list of tasks, permission is only read only, and now answer the question. It works for one question. But as the app grows, every feature has its own prompt, right? If the task rules or the permission changes, you have to update all the prompts manually. Small mistake means AI gives inconsistent answer. So these people started using RAG, which is retrieval augmented generation. So the idea was to store all your project data in a database and let AI fetch only what it needs. For example, AI fetches overdue tasks from the database when the user asks which tasks are overdue. Better, right? But still not perfect. AI does not automatically knows permission. It might fetch outdated data info if the database is changed. You still often end up repeating same context in multiple places. AI has no standard reliable way to know the context it needed. And that's why MCP was created to make context structured, reusable, and safe. But before MCP, we first need to know why context needs structure. By now, it's clear that AI cannot know anything unless we tell it. But here is the problem, we can't dump all the info everywhere. Let's take another example, a team collaboration app. So user asks, show me the tasks my team has not completed yet. To answer, AI needs who the user is, what their members are, task deadlines, permission for each task. AI needs all of them. If we just copy all this info into a prompt, the prompt gets huge. Every features repeat the same info. If anything changes like team members, rules or deadlines, we have to update multiple prompts. Mistake happens, we cannot store it into a text file or everywhere so that we can copy it and paste it. Anything can change, anyone can change it. So mistakes happens, AI gives wrong answers. It is like telling someone a story over and over, a word for word, instead of giving them a map, right, in a structured way. All we really need is a structured way to tell AI what's relevant. We need to give reusable pieces of context. We need to give rules for what AI can or cannot see. Without structure, context becomes messy, inconsistent, and expensive too. That's exactly the point where developer realized that we need a standard, structured way to pass context to AI and not with a giant repetitive prompt. And that's why MCP exists. So it makes context very organized, reusable, and safe. So far, we have seen the problem. AI does not know the user, it does not know our database. We keep repeating long prompts, and context is messy, inconsistent, and hard to maintain. For example, imagine that you are running a small library, and every day people come to ask which books are available, when is my borrowed book due, can I reserve a new book, and many more questions. So before MCP, the same problems like who the user is, what books they have borrowed, what books are available, and which books they can reserve. Every time it work, but it is slow, exhausting, and sometimes easy to make mistakes, right? Now imagine that you have a shared library dashboard, a single place that keeps all this info structured. You can see this is a dashboard, and here there are user details, there is a list of available books, and the permission user has. So basically, the librarian can instantly see who the user is, they can see which books are available, they can see what are they allowed to access. This is what exactly MCP does to AI. Understood? Instead of stuffing all the information into the prompt every single time, MCP gives the AI a structured way of context. AI can reuse context across questions. AI only sees what is allowed to see, and now the AI can answer which books are overdue, can this user reserve a book, without repeating the entire story every time, right? So in short, MCP is like giving AI a dashboard instead of making it memorize everything from the scratch. Now, how MCP works with an live weather example. So far, we have seen the problem. AI can be smart, but it does not know everything, right? So, for example, you can ask AI, what is the weather in Mumbai right now? AI is just a model. It does not have real time data. It can guess based on patterns or old knowledge, but it can't tell the current temperature. This is where MCP comes in. Think of MCP as a layer with tools and connections. In this case, MCP layer has a live weather tool that can fetch real-time updates from the weather API. So here is how it works. You ask the AI for the weather. AI checks the MCP layer if there is a tool for live weather. AI can see there is already a tool present. So MCP calls the weather tool, then the tool fetches the latest data and returns it to the AI in a form of structured way. Now AI gets the real-time data and it responds to user that right now it's 32 degrees Celsius and sunny in Mumbai. Notice the difference? The AI did not know or memorize anything. It just replied MCP to provide the context and live data. In short, MCP acts as a bridge between the AI and the real world, right? So it organizes context, provide tools, and make sure that AI can answer correctly even when it does not know the answer to them on its own. Now, what is the architecture for our MCP? So MCP or Model Context Protocol is a smart middle layer between your app and the AI. Its job is to organize context, provide tools, and make sure AI has always the right information without repeating the long prompts. So here is the breakdown. First is the context layer. This is where MCP stores all the structured information your AI might need. So for example, the user data, name, plan, references, then permissions, what user can or cannot access, app state, which is task, order, session info. Think of it like a library dashboard. The librarian does not memorize every book of it or the user. The dashboard shows exactly who borrowed what is available, and what rules to follow. Next is tools layer. So MCP can connect AI to external tools and APIs. So AI can fetch real-time or dynamic data as we had seen in the previous example. So each tool has a description. For example, this weather tool will have a description to fetch, helps to fetch live weather reports. This payment tool will have a description which will make sure that it is used to pay the outstanding dues. So each tool has a description and a function, so the AI knows when and how to use it. Understood? For example, this task manager get task list or deadlines from your app. So it have a description, returns active, overdue, or completed task for a given team or a user. So it will say UI that I will return active, overdue, or completed task for a given user or team whenever asked. So this makes AI the clear that this is the tool which is required for fetching the data related to task. This way, AI does not need to know or need to call APIs or fetch data. It just uses the MCP tools, and tools fetches data and returns it to the AI model. Third is the AI layer, where AI sits on the top of MCP. So when question comes in, it does not guess or reply on huge prompt. Instead, it checks the context, checks, call the appropriate tool whenever real-time data is needed, and generate the answer using accurate, up-to-date information. So flow in action, like with the real-world example, imagine user ask what is the weather in the Mumbai right now and can I upgrade my plan. So here is what happens. So AI receives the question, AI checks the MCP, weather tool is used to fetch the live weather, payment tool fetches the user current plan and eligibility for upgrade, MCP returns the structured data to the AI, and AI combines the info and the answer, beautifies it and returns it to the user saying that right now it's 32 degrees Celsius and sunny in Mumbai, you are on the basic plan and eligible to upgrade to premium. This is why architecture matter. So context is structured, there is no long prompts or repeated prompts, tools are documented and reusable, AI only accesses what it is allowed to see, AI answers are accurate and up to date and safe. So in short, MCP turns AI from a guessing machine into a smart assistant that actually know what he is talking about without relying on huge repeated prompts. Let's see one more real life MCP use case. Imagine a company building a smart travel assistant app. User can ask AI, what's the weather at my destination? Are there any flight delays? Or can I upgrade my hotel room? Without MCP, AI would have no idea about the user data, live updates, or booking details. Developers would have to stuff all this information to long prompts every time, and it is slow, messy, and error prone, which will cause a high token rate. So with MCP, company sets up a structured context layer containing user preferences, bookings, loyalty points, permissions, what each user can access, app state, flight, hotels, etc. So they create a tool layer where each tool clearly describes. Weather tool is just we had seen to fetch the real-time weather updates. Flight status tool checks real-time flight updates. So it will have a description of return flight delays, gate info, and boarding time. Hotel upgrade tool checks the eligibility and available plan for the hotels. It will have a description, for example, as returns, available room prices, and upgrade rules. So whenever user asks a question to the AI checks the MCP for relevant context, calls the appropriate tool, returns the structured data, and that structured data is beautified by the AI and returned back to the user. So, for example, if user says, is my flight to Paris on time and can I upgrade my hotel? So MCP fetches the flight status, also the hotel options. Then it will reply, your flight is delayed by 30 minutes. Your hotel has available premium rooms and you are eligible to upgrade. So here is the interesting part. Companies can also expose their MCP tools for other. So, for example, a weather service company can expose a weather tool to multiple AI apps. Then a payment platform can expose billing tool to partner apps. Developer don't need to build these tools themselves. They can just connect their AI to the MCP layer where other companies have exposed their MCP tools. So this creates a marketplace for reusable structured tools. AI does not need to memorize everything. The apps can safely share real-time updates or real-time capabilities with proper access control. So in short, MCP is not for the internal AI use. It allows companies to standardize content, safely expose tools, enable third-party AI application to leverage their data and services. This is how MCP turns AI into a smart model, into a truly connected, reliable assistant that can work with real-world apps and services. So what changes after MCP exists? Before MCP, building AI features in real app was really messy. We had seen in the previous slides. So developer has to repeat long prompts every question. AI does not know who the user was, what data it could access, or what is the current state of app. It was slow, expensive, and prone to errors. So after MCP, everything changed. Now the AI gets structured context. It knows who the user is, what permission they have, and what tools are available. No more repeated prompts, no more guessing, no more inconsistent answers. So think about a travel assistant app, which we had seen in the previous slide. User ask, is my flight on time? Developer dump before before MCP, developer used to dump all the data into the prompt, and which might give wrong answer if prompt was not updated perfectly. But after MCP checks the context and flight tool. The flight tool will give the proper information to the AI model, and then AI model will return that data saying that your flight is delayed by 30 minutes to the user. So efficiency improved, scalability also improved, safety, AI only sees what is allowed, and reusability, tools and context can be shared across multiple apps or teams. So in short, after MCP exists, AI stops guessing and start actually knowing what it is talking about. It turns AI into a smart but forgetful assistant, into a reliable context aware helper for the real world apps. So that's how MCP changes everything from messy repeated prompts and confused AI. We now have a structured reliable layer that organizes context, connect tool, and makes AI actually useful in real world app. For it is faster, safer, and scalable, and it opens the door for developers to build AI features without constantly worrying about context or repeating information, which we had seen. In the next video, we will put all this into action. We will build a simple MCP server for weather application, and I will show you step by step how AI can fetch real-time weather updates using MCP tools. So if you want to see MCP in action and learn how to connect AI to live data, make sure you don't miss the next video. Thank you.